Welcome to the Practical Data Lunch and Learn. So today we have Chris Crane from FiveOneFour. He's going to be talking about the Moose Stack and some other stuff. So it's going to be really awesome. I met Chris, I think he was at Snowflake Summit, I believe. And
Right.
this project that seems super cool. And so I'm going to let him introduce himself and take it away. So.
Cool. Thanks, Joe. Appreciate it. Yeah, I'm Chris Crane. I'm one of the co-founders here at FiveOneFour, and our mission is to bring great developer experiences to the data and analytics stack. Thank you, Joe, for having me here. Thanks to the community. Excited to chat with you all. My plan here is I want to share a little bit about kind of the vision for our company and the product and like our take on the market and where we think we fit in it. And then I want to jump into an actual demo and get hands-on in some code. I figure that would be interesting for this audience, but I also don't want to just talk at everyone for 30 minutes or an hour or however long this goes. So please feel free to interrupt me with questions, comments. Would love to have this be conversational. I'll try to keep an eye on the chat on the side as well, but I might miss that as I'm presenting. So feel free to just jump in and interrupt me if any questions or comments come up. So yeah, with that, so a little bit of background, this is actually the second company I've started with this founding team. The first one was a data pipelining and ETL company called Datalog. And we ended up getting acquired by Nike and went in and led global data engineering at Nike. So my co-founder, our CEO, had a team of hundreds of data engineers building out all the different data workloads at Nike, and learned a ton from that experience, and left a couple years ago to start FiveOneFour. And maybe I've got a couple slides here just kind of to share this. The opportunity that we see here that kind of came out of that is, we see here, we like to say that data and analytics are moving from report fast to conversation fast. And that's frankly some kind of silly marketing talk. But what I mean by that is we're seeing more and more opportunities where data and analytics is moving from this world where it was kind of started in BI and the world of reports and dashboards. And more opportunities are arising now where analytics are becoming more and more core to application experiences, with analytics getting embedded in end user facing applications as a main driver of engagement and retention and upsell. We see development teams within business units building out more and more automations to power the business, whether that be recommendations to actual users or actually taking action on behalf of users to run the business. And then, of course, now AI is everywhere, and we're seeing more and more of this kind of natural language chat. And across all of these, it's moving from a world where you need like response times measured in seconds for reports to milliseconds to be powering applications, powering natural language chat. And I think what's really interesting is like across all these different use cases, we're seeing both software development teams creeping more and more into using data and engineering infrastructure, or data engineering and data and analytics infrastructure, and having to incorporate that analytical infrastructure into their web applications. And we're seeing more and more data engineering teams kind of creeping into the software development, application development world. And there's this really interesting convergence of software, like classic application software development and the data engineering specialty of software development in this world of kind of modern data and analytics use cases. And the missing component here seems to be the software interfaces and the developer experience in order to enable these. So what we see is that if you're coming from a software development background, an application development background, you want to incorporate analytics into your application, you're likely reaching for what you know best, which is your transactional database. You're building on top of Postgres, you're building on top of MySQL. This is what's already powering your application. And there's a pretty great developer experience around this type of infrastructure because software teams have been building applications on this for decades. There's tooling, there's best practices. And but then the challenge is, of course, that infrastructure is built for transactional workloads, and it doesn't scale for these new analytical workloads. And then alternatively, if you're coming from more the data engineering world, you might be reaching for like a modern cloud native data warehousing or data lake solution, or kind of analytical backend like a Redshift or a BigQuery or a Snowflake or a Databricks. And here you've got the infrastructure that's actually built for analytics, so it's going to scale better than your transactional backend, but it tends to be built for these legacy BI use cases and is not really designed for a modern software developer experience where you're trying to build applications or build AI on top of it. And we've seen this rise now and this kind of explosion of popularity of a new wave of analytical infrastructure that's things like DuckDB or Druid, or especially ClickHouse has emerged as a really popular database that's being embraced by both software developers and data engineers for building these kind of custom applications on top of. And yeah, that's where we want to fit in. So what we built at FiveOneFour is this developer toolkit that's sits on top of some of this next generation kind of best in class open source analytical infrastructure like ClickHouse, and provides hopefully a world-class developer experience on top of that, so that you can build out custom applications on top of this infrastructure. You can build out automations, you can build out AI interfaces and experiences. And we've done this primarily by building MooStack. MooStack is our open source framework. It's available in TypeScript and Python. It surfaces up a bunch of libraries and tools and modules that provide developer interfaces on top of different components of this underlying analytical infrastructure. That's what I want to spend most of the time talking about today, and showing to the community here and getting your feedback on. The way we make our money is with our cloud platform, Boreal, which makes it really easy to get into production with any application or any module that you've built with MooStack on top of this infrastructure. And then finally, we've also invested a ton in, or we're starting to invest a lot in our AI Copilot enhancer, which is under the hood essentially just an MCP for MooStack, but enhances your Copilot of choice in building out these types of data-powered or analytical applications. Okay, maybe pause for a second for any comments or questions before I jump deeper into the product. But yeah, that's kind of where we're coming from. Cool.
Still mapping all of this in my head. So keep going. Thank you.
Okay, cool. Thanks, John. Okay, so what I want to show next is two reference architectures. These are architectures for the two most common use cases that we see teams building with the MooStack on. The first is what I'll call user-facing analytics. You might hear me abbreviate this UFA. This is where tends to be the more kind of software application-focused use case. You've got a front end. This front end might be facing your end users, it might be facing internal users, but it's likely got some transactional components. Maybe it's got some search and retrieval components, and those components each have their own dedicated backend. But now you're wanting to either introduce analytical components to that application or optimize the performance of those analytical components, so you're not getting spinners in your dashboard if it's currently powered off of Postgres. And that's where the MooStack comes in. So you can see here different modules of the MooStack are associated with different areas of the underlying infrastructure, but you can build out data pipelines to replicate the data across your different backends, ingest it from other sources. There's modules for establishing the different underlying infrastructure to power this, and then the different interfaces that you want to be able to pull this data into your front end, whether that's APIs for software connecting to it or MCPs for AI connecting to it. And Moose is really designed from the core to be very modular. So if you've already got a CDC solution of choice in place, or if you've already got an API framework of choice in place, you don't have to adopt all these modules. You can pick and choose, adopt from like wherever you're going to get the most value from the start. And then as you adopt more, you should see kind of more value as these as you get the horizontal integration from the different modules, but that's not required. And I'll show this more in the demo as I get into the actual code of what that looks like. The other very common use case we see is what I'll call an operational data warehouse, or ODW. And with this is more kind of coming from the classic data engineering world, but where you're building out a data warehouse that is not necessarily like primarily targeting BI or dashboarding. It of course can serve that use case. But if you want to be capturing data, unifying data, and then building custom applications, building custom automations, building custom AI implementations on top of that data, then you're likely looking at an architecture like this, where you're going to be using the same modules, but with kind of a different mindset, where you're aggregating data from different places, landing it in your data warehouse, and then surfacing up the programmatic interfaces to build the different automations and AI use cases for whatever you're trying to do within the business on that data warehouse.
So Chris, this looks kind of like visually, this kind of reminds me of a lakehouse kind of architecture. How can you speak to how this is different than that? Like, because I'm seeing streaming into storage, very data lake style in appearance, and then you've got the analytical DB on there. How does this differ?
I think the short answer is it's probably not different. Like this is a classic data warehouse or data lake architecture. What we're trying to introduce here is the developer experience on top of that, to make it really easy for you to create an entire data lake architecture like this in code, in the language of your choice, with software development best practices, so that you can then interface with that with building custom applications or AI on top of it. So I don't think it's necessarily like a strong change in the underlying architecture. It's in the way that you're building and interacting with and extending that architecture into the different use cases. That's the difference we're trying to bring.
Well, and you use the keyword developer here too, and maybe you want to unpack who you mean by that persona.
Yeah, it's a really interesting question, because I certainly don't want to come out and say that like data engineers aren't developers, because I think many data engineers are developers. But I think that there's plenty of folks that are coming from more of a, like, say, data analyst background, that may be wearing a data engineering hat now and are very comfortable with point and click interfaces, with kind of GUI based data pipelining or GUI based visualizations. And the persona that we're targeting could be called a data engineer, could be called an analytical engineer, could just be called a developer, could be called a software engineer. But it's anyone who's trying to approach this kind of architecture with a software best practices mindset, and with a use case in mind of building out actual applications that are powered by this data, applications that will be built on top of APIs or built on top of MCPs, and wanting to get a kind of best-in-class developer experience there for building out those use cases.
Thank you. That clarifies.
Cool. The next slide actually, I think, speaks to this a bunch more. When we started this company, we tried to lay out, like, what does a great DX for data and analytics actually mean? What should the kind of core principles here be? And I want to put these forward here, but I also want to put it forward in the context of some actual Moose Stack code here. And by the way, this is Python in the example here. Like I mentioned, we also offer TypeScript. I can show either one, and I can do either one in the demo. I'm kind of curious if folks on the line have a preference for TypeScript or Python as a language of choice.
Preference, but more familiarity with Python. I don't know. I won't say preference, because I don't know enough about the other.
I like Python. I also like TypeScript. So, what was the third one?
Just those two.
Was it okay? This is my chocolate and vanilla. I think it just depends.
I can
right?
show some of both too.
What's it? Yeah, for data people, I'm guessing Python's going to be by far the more familiar one. Whereas I think when we talked too, it was interesting. So I brought up like, whoa, it's TypeScript. That's interesting. But then you mentioned this is what the devs code in, right? Like that is
exactly.
Which so yeah.
Yeah, what we find is that for folks coming more from the data engineering background, there tends to be more familiarity with Python. That tends to be kind of the easier entry path. For folks who have a React application, say that they've already built very TypeScript native, then the TypeScript kind of entry point tends to be much easier to get to. Let's say this. I'll show Python, but I can also flash some TypeScript throughout the demo as well. In reality, the interfaces look very similar between the two. It's the same kind of core concepts that we've used in the framework for both languages. In any case, what you see here is the simplest version of essentially an end-to-end application built with the Moose stack. So there's actually 5 different modules used in these 25 lines of code. And in these 25 lines of code, I've essentially codified this entire architecture where I've got data ingest, I've got a streaming buffer, I've got an analytical database with the OLAP tables I'm creating, and then I'm exposing data over an API endpoint. And what you can see is that the data models or the data contracts are defined as native objects within your language of choice. So in Python, that's going to be a class. In TypeScript, that's going to be an interface. And then that data model or that data contract is used across your entire code base and is instantiated across your entire infrastructure. So you get this type consistency across the different elements of your infrastructure, which kind of brings me to the first couple principles, which is that we wanted this to look just like regular application software development, in that we didn't want you to have to be developing in like a custom browser-based IDE. We wanted to have you in your local IDE with your like native Git integration, not some kind of jerry-rigged GitHub integration from the cloud. We wanted you to have a local developer experience where one of the core capabilities of the Moose stack is the Moose dev server. And I'll show you this in the demo, but in a single command, Moose dev, you can spin up an entire local replica of your production data and analytics stack so that that's running locally next to your application code, whether that's in React or whatever you're using for your front-end application. And you get this development experience where you're developing your analytical backend in conjunction with the rest of your application, and you're validating it all locally. You're getting type checking in your IDE, and it's not like YAML based, for example. I don't mean this too pejoratively, but like it's real programming languages that have linting and autocomplete and everything that you'd expect as you're developing on an application in your IDE. So just by having this be native framework that's native to Python and TypeScript, you get all these kind of software development best practices natively out of the box for when you're building the application. Principle number 4 is we wanted to bring in a bunch of abstractions to make developing with this infrastructure easier. Like when you're building a web application, you don't have to go in and architect your own router every time. You use like Next.js's router or Tanstack's router. And there's a bunch of kind of equivalent things in the data engineering world where, for example, if you want to create a streaming ingest pattern where you want to put a streaming buffer in front of your analytical database, there's a bunch of like glue and duct tape you have to write to connect your stream to your database. And we don't want you to have to reinvent the wheel every time you do that. It's hard, but it's not exactly like, it doesn't need to be different for every use case. So what you see here is that when you define a table as a Moose OLAP table object, then when you define a stream, you can just set the destination as the table that you just defined. And under the hood, what Moose is going to do for you is provide all of the glue and duct tape to connect that together with best practices. So we're going to ensure at least once delivery to your database. We're going to automatically batch writes into the OLAP database to maximize performance of that OLAP database, which is generally a best practice when you're writing into columnar databases. There's, so there's kind of, I don't want to talk too much about this, but there's a bunch of kind of abstractions of the infrastructure that we build into the framework for you so that you don't have to worry about that, and you can focus on what's the actual business logic of my application that I'm trying to build here. Modularization, we already talked about. The kind of horizontal integration part of it is this data model becomes a single source of truth across all of the different components of your infrastructure, so that if something changes upstream in your source data and you need to reflect that through your API, your stream, your database, your analytical API, you can do that all in a single code base and in fact in a single data model. Open source native is super important to us. We're big believers in the open source community and the power of open source and not having vendor lock-in with what you're building with these applications. That's why we've open sourced the entire Moose Stack framework. AI Copilot native is one that I think is really interesting. What we found is that the types of developer experiences that enable a human developer also tend to be very effective at enabling an agentic or LLM developer. So when you use common patterns that there's lots of examples of out there in the development world with like languages like TypeScript or Python, it makes it easier to develop. When you provide abstractions on top of underlying infrastructure and reduce the surface area of what a developer has to interact with, it accelerates the developer. And then especially this local developer environment where as you're writing code, the Moose Dev Server is automatically going to hot swap in that code, implement the changes in real time in your local dev server. You're going to get immediate feedback. And all of that feedback becomes context that you can feed back into your Copilot. So if you're getting error logs, if you're getting status codes, if you're getting compilation errors, all of this becomes something that lets you iterate really quickly, not just as a developer, but enables your agentic Copilot to iterate very quickly as well. And then finally, yeah, I talked a little bit about GitHub integration already, but like that's really core here. This is some of what we bring with Boreal, with our cloud platform. But Moose Stack comes with migrations as a core module as well, which I can show a little bit in the demo if people are interested. But we tried to make it a really seamless path from developing locally to identifying differences between the current state of your application and your production application, making it really seamless and transparent to migrate through that. And also enabling like really standard software development best practices like CI/CD, like doing unit testing, like creating staging environments. All of that becomes much more kind of easy to implement in native when you're working with native languages and a native IDE. Okay, let me pull up for a second again, and I think I want to jump into a demo from here, but curious if this is sparking any comments or questions. Anything controversial here? Anyone want to call BS on me on any of this?
Has anyone done that?
Called BS on any of this?
Yeah.
No is probably the short answer. I think there's I think it can be a little bit controversial telling folks that the way they've been doing things for decades is maybe not embracing a bunch of best practices that have been like evolved in this other community over here. And I think there's lots of people in the data engineering world who are already like way ahead of us in this. Like, I don't want to take credit for coming up with these ideas. Like, lots of this is just like software development best practices, and many data engineers are already trying to implement these or have found ways to implement these within their world. At Nike, we found it very difficult to implement a lot of these in a kind of cloud-focused data engineering platform world. And that's what drove a bunch of the inspiration for creating a framework that makes it much easier, and like you don't have to jump over a bunch of hurdles and create a bunch of like pain, or like have an entire platform team that's dedicated to creating these kind of experiences for the team that wants to build with this.
Oh, I wish I would have had this at a few startups I was at, just because, you know, we were having to, you know, I was sort of the cross between the software engineer and the data engineer and the data lead and everything. But it was countless times it was having to roll your own. This is, you know, a while ago at this point, but I definitely wish I had something like this, and I wish the software engineers did something like this too, where they could just write JavaScript. It works, you know, because we were a Django JavaScript shop, right? So it was just you know, we're having to handle all this crap in Python, and then, you know, they would try and conform that back to the back end in Django, and it was just a total pain in the ass. You know, so I wish something like this was around. But it is one of these things where I feel like the world, I think DBT ran into this early on too, where people were saying, you know, this when it first came out, because I remember like some things I read was like, well, I could just, you know, what's wrong with the old way we were doing stuff, right? But I think they're trying to introduce software engineering principles to you know, to SQL workflows and data modeling and so forth. I see this as being very analogous, just about 10 years removed from that time, but yeah. So,
but Joe, you know,
earlier,
I was going to say earlier this year, even I was having a conversation with an associate who, you know, we were talking about how is it still so hard to plug in CI/CD to most of the data engineering pipelines. Like it's not, there's no easy button to mash. And this looks to me like if it's not a full easy button, it's a mostly easy button compared to some like DBT does a good job of it, right? Like that's built in for DBT, and that's one of their value propositions to say, well, you know, you can build a data pipeline, and also, by the way, you can still do some software best practices. But a lot of the other systems don't really have that easy button. So that's one of the things to me that I find real interesting about this, because it's still not ubiquitous. Like a lot of us wouldn't have jobs today if everybody had figured out how to do data warehouses so far.
Yeah. I kind of see this as being like sort of a bit of an evolution from what Streamlit was doing too, where they were making very easy to use, you know, composable UI widgets for data apps, but not data powered apps, right? That's a big, I think, difference. But they, you know, to use Streamlit, it was like dead simple, right? It's like cool, couple function calls, and I got, you know, awesome visualizations. And I think this is a lot more involved, obviously. But yeah, but I don't know. It's a good question, John. Like, why is it that data warehousing is still hard to do? Let me see, only almost 40 years after Bill Inman came up with it. I don't know. That's a good question.
Some of it feels like it should be solved problems by now. And some like the SDLC components of it, I find aren't sort of like intellectually native to the data warehouse community.
Yeah. I don't know how like theoretical we want to get here, but I think that's starting to hit the nail on the head. And I think there's a lot of like history behind it, that a lot of the data engineering community and those workloads came from like the IT world and needing to create reports for the business, needing to create dashboards. And that's like a very like a point and click business analyst kind of friendly world. And then as the infrastructure got more and more complicated, data engineering emerged as a specialization necessary to support this. But it wasn't, there's much less of like a shared history with the application development world that was developing all these best practices. And then I think with the whole move to the cloud over the past 10 or 20 years and the rise of these cloud native data engineering platforms, they're really powerful and have provided like an easier path to production for these like classic data engineering workloads. But the fact that they're cloud native actually undermines a bunch of these software development best practices, where like in order to even start to broach the CI/CD world, you need to have it like running locally first, and then be pushing it into the cloud and running it through your CI/CD process in order to get there. And if you deploy to the cloud by just like dropping code into a browser-based config and just like YOLOing it, then there's no native place to bring CI/CD into that world.
Yeah, I think this is an evolving space that needs more help, because it to your point, it just doesn't feel like there's an easy button yet.
Yeah.
So that's what I'm real interested here. because this does sort of echo back to a few years ago working in AWS. I had a title of, I was an application developer in air quotes, but I did data pipelines, right? And so, you know, it was CI/CD, and it was actually an on-prem GitLab instance. And so it was this kind of hybrid space with on-prem Hadoop and AWS Cloud Hadoop, and it was it was a lot of complexity, like just figuring out the definition of local when you have 3 different you know spaces that you're working in. There was a certain amount of logical gymnastics. So yeah, carry on, demo on.
Yeah.
I'm excited to see what you got.
Cool. All right, let's get into some actual code here. All right, I'm gonna pull up my IDE. Where do I want to start here? Okay, so the demo I want to show is based on essentially an operational data warehouse use case that I frankly vibe coded yesterday over the course of like an hour. And what you'll see is that this is based on aircraft transponder data as the source data. So I think I can show this real quick. It's this ADSB API, pretty fun set of data. It's got kind of transponder data for all the aircraft in the air at any given time. So I use this API as the source data, and the output I eventually got to is this. This is a front end that Cursor generated entirely for me with a little bit of prompt in. But it's like a fully custom application built on top of this data warehouse. And what I want to show you is how I then used MooStack to develop everything in between. So we've essentially got an API as the example source data here. We've got a custom React application as the output. And I'll show you all the different things that got built in the middle. So when I come into my IDE, whenever I'm developing with Moose, the first thing I'm going to do is start my Moose dev server. Actually, by the way, is this code tiny for all of you? I suspect I should zoom in a little bit more. I'm on a pretty large monitor. How is this legible now?
Yeah.
Okay, cool. Let's see, we don't need to see that. I can give it a little more space here. So I'm going to run Moose dev. What this is going to do is spin up in a local development environment for me. So in this case, it's going to spin up ClickHouse in a container, which is one of the really cool features of ClickHouse, that it can scale to like massive petabyte scale, but also can run in a lightweight container on your laptop. It's going to spin up Red Panda for streaming in a container with Kafka native topics. It's going to spin up Temporal for my orchestration, my workload flow orchestration. And it's going to spin up, in this case, a Python runtime, although it would be a TypeScript runtime if I was in a TypeScript application. And it's going to piece all those things together. And now as I'm developing, I get my code actually running locally as I'm developing it. So now the front end I just showed you, if I refresh this, we should see, yep, everything's working. I've now got more aircraft than I had a minute ago. And yeah, I'm now set up to build out different things and see if it's actually flowing through successfully all the way to my front end before I then try to, commit my branch and go to production. Okay, so data models are the core of every Moose application. That's what I mentioned before. So in my Moose app here, there's just a convention. We find it's helpful to bucket the different modules into different folders, although that's not required. But I've got my models.py file here, which is defining the data models that I want to use in my data warehouse, my data contracts. Just a native Python class, like I said before. This class, in this case, was generated by Cursor just by hitting the API endpoint that I pointed it to and say, hey, generate a class for me that matches that. And these are all just native Python classes. You can actually extend this data model. It's a Pydantic data model under the hood. You can extend this with ClickHouse native classes as well, which will then be implemented at the database level. But you have your Python or Pydantic native classes here as well, so I can get type checking kind of throughout my code base as I'm building this. We also get that like I can extend this data model. So I've got I want to actually process that aircraft tracking data in flight in stream before I land it in my database. So I've got a derivative data model that I defined here. And this just extends the basic Python model. And what this means is I get lineage embedded in my code. So I don't have to, like, I could import this into my data catalog of choice if I want, but I've got my source of truth of my different data models and how they're dependent on each other. So I've got my data models defined here. Now I want to start to instantiate this as elements in my underlying infrastructure. And that's where Moose comes in. So far, we've just been looking at Python and Pydantic. Where Moose comes in is, let's look at ingest. So what I'm doing here, this will look familiar from the code that I flashed up before, but I'm importing my data models from my other model file. And this is pretty cool because I can if someone else is developing on this code base, they can just import these data models into what they're developing. Like this starts to scale across a team that's trying to use these data models as a source of truth. But I'm importing these models. I'm first instantiating a table in my ClickHouse database that's typed to this data model. Then I'm instantiating a streaming buffer in front of that table that's again typed to this data model. And then I'm instantiating an ingest API that's typed to this data model and connecting them together with this destination setting. I talked about boilerplate abstraction before. With this ingest API, you get a bunch of stuff for you kind of under the hood, like out of the box. So this is this API is going to be in a high performance, secure Rust-based web server. It's going to have runtime type validation automatically. And what I've added here is one line of code to give me a dead letter queue so that if data comes in, fails that validation, I don't just drop it on the ground. I'm now shunting it into a dead letter queue, which in this case is a red panda stream. And then I want to define my my derivative data infrastructure. So I don't actually need an ingest API for the processed data model. I just want to create a stream and a table in this case. And then you might be wondering now, how do I actually transform the data from aircraft tracking data into aircraft tracking processed? And you're going to do that with streaming functions with the Moose streaming module. And again, this is all like trying to be as native to Python as possible. So you do this by taking the stream object we just defined, saying, all right, I want to add a transformation to that. The transformation that I want to add is this transform aircraft function, which I'll show you in a second. And what this is going to do is tell Moose to automatically pull every event that goes into that tracking data stream, process it through this function, and then push the output to the downstream stream. So with a couple lines of code, I've automatically orchestrated my streaming function here. And you'll notice this streaming function uses my data model. So it takes aircraft tracking data model as an input, it returns aircraft tracking processed as an output. And if I have any type mismatching there, I'm going to get an error as I'm developing here within my IDE, which is just with my native Python linted. So let's check out this function. Got the function in my functions folder. This is where I've got all my shared functions. Again, like another team could import this function and use it in some other place if we have like a standard definition of how we transform data in a particular way within our application. But here's the function definition. It's pretty simple. I'm not doing any advanced transformation on this data, but I'm adding a couple fields to it, doing a little bit of refactoring of two of the fields. And you can see in my local dev server output here that I've got a workflow running every 30 seconds that's pulling data from the source API, pushing it to my ingest API endpoint. You can see here where the messages are getting hit. And then each of those messages is getting received and then processed through the streaming function, and then ultimately written to the underlying database. And in this case, I'm saving both the raw source data and the process data, but you wouldn't necessarily have to do that. Okay, that's the ingest flow. So we've gotten from.
Is
yeah,
that
please go ahead.
Is that creating CDC on that as well?
This is not a CDC example, so this is pulling from an API, but you absolutely could do CDC with this. And for example, we've got another reference application that I could share where You can integrate with Debezium or whatever your like CDC event generator of choice is, and then ingest that in. Or you could build your own fully custom CDC implementation using these primitives if you wanted to.
Yeah, this again, I don't like solving problems that are already solved.
Yeah, exactly. The ClickHouse themselves, they also have a bunch of great CDC solutions that are ClickHouse specific. They've got PeerDB, which is an open source option, and then ClickPipes is their commercial option. We'll integrate very natively with those as well if teams are using this.
Nice.
Cool. I'll flash up the workflow as well really quick. That's going to be in my connector folder. I've got this, again, just series of Python functions, just standard Python functions that are hitting the source API, processing that data into my aircraft tracking data model. So again, I've got that model type checking kind of consistent through everything. Here you can see we're getting the source data and mapping it to the expected data model. Pretty basic mapping, just ensuring that there's like default values in that mapping. And then where the Moose magic comes in again is we take all these native functions and say, all right, I want to create a Moose task, which is a primitive based on temporal under the hood, and say the task is to run this function where we actually fetch the data. You get some configuration on that, like how many retries you want, what the timeout configuration you want it to be, and then create a workflow with a schedule in that workflow where it's running every 30 seconds, and the workflow runs this specific task. There's a bunch more you can do with workflows and tasks that I don't want to go too far down this rabbit hole. But if you're in the world of like data pipelining and needing to orchestrate arbitrary scripts in either Python or TypeScript, this can be a pretty powerful abstraction to give you those data pipelines and those workflows, in code in your local IDE, running locally through CI/CD, et cetera, bringing all the best practices to that kind of part of the development workflow. And then finally, so we've got the data landing in our database. Now we want to actually surface it up to the front end. So we need an API to do that. And we'll see here what the API looks like. Again, it's very moosey in that it's using data models, it's using kind of typecasting throughout. We've got a class that we defined for the parameters that we want to expose on that API endpoint. We've got a class for the structure of the JSON that we want to return from the API endpoint. And then we've got a function that orchestrates the SQL query against the underlying database. And what you'll see is that instead of having to hard code in the table and column names that I want to hit in the underlying database, I can actually use the object that I defined before. So I'm pulling in that aircraft tracking process table, and I'm using the columns and the name from that table, which gives me nice things like type checking and autocomplete. So as I'm typing, like it knows the category is an option here. And I'm going to know at dev time if I'm referencing here. I just saved the file, by the way, and you can see that it's hot swapping in the changes there. I'm going to know at dev time if I'm trying to reference a column that doesn't exist. So I know ORM can be a controversial word in this world, but and we're not trying to bring like a full holistic ORM to the world of OLAP databases. There's a bunch of reasons why that doesn't work particularly well that I'm happy to go into if people are interested. But what we are trying to do in this case is bring some of the best aspects of ORMs, like getting schemas as code, keeping your code in sync with your underlying infrastructure, and then being able to use those code objects to ensure the safety and structure of your SQL queries as you're hitting on the underlying database. And then, yeah, the only, again, Moose specific part of this is using the API module to say, hey, I want to create a new API that takes these parameters, returns this result, and orchestrates this underlying function. And with these couple lines of code, you're going to get, again, a high performance API endpoint. Moose is going to automatically document this API for you. So I get an open API documentation YAML file here, which I can open up in my Swagger client of choice. And you see here, like, here are the APIs that have been created. Here's the ingest API that the data is coming into. Here's the consumption API that the front end can hit. And because this is all automatically running locally, like I can immediately try out this API endpoint and see if it actually works. And cool, it worked. I got a 200. I'm not getting any results because I'm not, I've got values here that don't make sense. Here we go. Now we're getting aircraft results immediately in the API. And then what this lets me do is, oh, I haven't talked about the AI side of this at all. Let me flash that up as well. So I mentioned we've got an MCP server. That MCP server is really easy to get up and running locally with your Moose project. It's a single command install. You'll see in my cursor settings, I'm now integrated with this MCP. It's called Sloan. And that lets me start to have conversations with the underlying data in my infrastructure and actually co-pilot my development. So a bunch of the development here that I vibe coded yesterday was actually done with this AI. Let me see if I can give you an example of something I did. Oh yeah, this is a fun one. So when I actually created this API endpoint, I started this conversation saying, okay, how does my company define speed and altitude for aircraft? And what the MCP is going to do is do RAG retrieval on context that it has available. So it's going to learn like, okay, at my company specifically, speed and altitude are defined this way. Speed is aircraft speed, not ground speed. Altitude is barometric altitude, not geometric altitude. But we make it pretty easy to feed in like your company wiki or whatever source of truth you might have about best practices or data definitions or rules or whatever it is that you want to be informing your development. And then that's available to your co-pilot as it's helping you code. And then I say, all right, create a new API endpoint for me that surfaces speed and altitude for different aircraft types. Use the definitions you just gave me. And now my LLM is going to go out and start calling the tools that I make available to it through this MCP. So it's going to be able to read my project. It's going to read the underlying tables and see what kind of data is available there. And then it's going to actually go out and write the API. And in this case, it one-shotted the API. And so then when it went to test it, it got it right. But if it hadn't one-shotted it, the like error codes, the logs, all of that's available to the LLM to iterate locally until it can get it right, what it's actually trying to develop. And then because I have this documented API, I was able to say, hey, can you just create a custom dashboard for me in my front end that utilizes the data that you just created over that API? And that's how we landed with this output here. Okay, that was a whirlwind. We're actually running out of time. I didn't expect to go this long. I could, curious if there's questions people have. I'm happy to go to like Q&A now. If people are interested, we could do a little bit of vibe coding together and like I could show you what that looks like. All right, any preference? Yeah, thumbs up, Joe.
I always love watching people vibe code. It's yeah.
Let's do it. I'll pray to the demo gods. I did this last night and it worked pretty well. So let me see if I can reproduce it. One thing I thought could be fun was creating a new API endpoint on the fly and introducing that into my custom application. So what I thought would be interesting is like, all right, what if there's a specific flight that I'm interested in that I want to get data on and I want to provide an experience to my user where they can just like punch in a flight and get all the data about that. So let's see if we can make this happen. So create a new API endpoint for me that surfaces all the data on a particular flight. All right, so it's exploring what data models are available. It read my models file, which is where I've got the source of truth models. That's great. Now it's looking at the existing API endpoint. It's probably going to use that as a reference. Yep, I understand the data structure. That's great. And now it's going to try to actually write this egress API. What happened here? Oh, you know, I think I actually ran out of Anthropic credits last night. So it's going to try to do it without using the tool, but actually just going straight through the cursor generation here. Okay, so here's the new API endpoint. It just automatically generated. You can see my infrastructure has hot reloaded that change there. Now it's going to try to test the API endpoint. All right, it found that the API endpoint wasn't working because it was expecting a particular parameter. Now it's trying to fix that. So this is that iteration cycle that's enabled by having the whole local development environment, which is pretty sweet. Now we see that it actually looks like it successfully executed the API, but it might not have gotten the data back that it wanted. So it's trying to fix the pattern here. Okay, now we see it ran the API and it successfully executed a SQL query against the underlying database. Cool. Now it's going to try curling that. Let's see what it gets. Seems to think that it's not working, but I wonder if it actually is. Let me pause this for a second. Let's go back to our automatically generated API documentation. Here's the new API I just created. It seems like, let's see, give me an example flight code from my data that I can use to test the API. All right, so now it's reading from my database. We've got some testing options. Let's try one of these. I don't think we need any of this. No, still getting an error code. Okay, that's frustrating. Let's see. So the other thing I can do is go to my logs.
Can I just call out that it's frustrating here, but also this would have taken like 100 hours.
That's awesome. Let's see. Okay, my logs are getting flooded by the ingest happening, and we've got about 1 minute left. So I'm going to call off the vibe coding session here, but we're very close. You can see we've got an API defined. We've got it is actually executing SQL against the underlying database. I'm not sure why it's not successfully returning the data. But now that we've got the documented API here, what I could do is say like, okay, now add an interface to my front end that lets a user ask about a given flight. And what it'll do is hopefully use this documentation to go update my front end and drop something in there. Probably take a couple minutes to do it. But yeah, that's the kind of workflow that's enabled here. And then we didn't even get into the like productionization side of this, but essentially what would happen is once all these changes are done, what you can do is, I'll show this really quick. You can run Moose plan, and I give it the URL of my production Moose application along with my token. And what it's going to do is say, okay, here's the plan. If you try to push this into production, here's everything that's going to change. I'm going to reset these tables. I'm going to add this new API endpoint. These other API endpoints aren't changing. And then what this can actually do is store all of this, store this entire plan in a YAML that I can then review, confirm, integrate into my CI/CD pipeline. I can have it post that plan to Slack before it goes to production. Like all of this becomes tooling that I can use in my local to cloud workflow. And I have to do a little bit of a plug then that if you want the easiest path to do this, you use Boreal Cloud, which is our hosted offering for it. And I think maybe I'll call it there. I'm happy to run long if people have or more comments or questions though.
Oh man, we're at time already. That flew by.
It really did, yeah.
Super cool. Super cool. Thanks for sharing.
Yeah, totally. Can I ask what about this is cool in your mind?
I mean, it kind of reads like like declarative pipelines, but all inclusive. Like, you know, it's like all of the things that Databricks just released that are like most people don't really know about, and they may not be comfortable with it because it's you know, it's in a space they're not familiar with. I think it's great the way that it works together with itself and creates the connectivity on that, what you might call the last mile on both ends.
Love it. Thank you.
What's next for you? Oh, so were you gonna ask a question? I don't want to like monopolize like I always do.
Yeah,
I'll ask a question.
I just had a comment.
Okay. Go.
Yeah.
Go for it.
I think the setup that Chris, you have shown earlier when we wanted to like get data from Kafka towards ClickHouse, right? It for me it felt like TOML file basically, where you give set of configurations to particular task, and then it kind of expects a couple of inputs there, and then this one your framework kind of sorts of owns the task, and then it will just you kind of hand it off to your framework with that sort of this one, be it transformations, be it ingestion, be it whatever the task it is. So that's how I felt. Just really good, because most of the times the data of movement, quote unquote, belongs to these kind of tasks, not very custom, not very like this one reinventing the wheel basically. So which is really cool. I think I really got that, like, which is what Spark / Databricks / Snowflake try to do with their data apps and with Streamlit and whatnot, right?
Yeah.
So yeah, that's really cool. Yeah.
That's awesome. And yeah, I think I've seen a lot of examples out in the wild of companies building custom framework abstractions on top of Databricks or Snowflake or whatever it is that they're using, where they're giving ways for their engineers to define in a TOML or in a YAML, like some kind of configuration file, what like business logic or data flow they want to actually execute. And even in itself is like a huge step in the right direction, because you're at least like codifying your data pipelines. It's in code. You can version control it. You can bring like Git into the world. But what we've tried to do is take kind of inspiration from that and take it one step further, which is now it's in native Python and TypeScript. So you get the type checking, you get the local compilation, you get the kind of integrating this into a broader application, which can be really difficult if you're, like YAML or TOML are not development languages. They're great for what they are, which is like capturing configuration. But trying to build an application on that tends to introduce a lot of like paper cuts and pain, I found.
Yeah. Is your focus directly like related to creating an interface through MoStack, where you could integrate these data apps very much easily as any other API integrations or any systems integrations, like directly with the data warehouse or data systems that is written with the MoStack towards broader stack of the applications in quote unquote enterprise or any other companies basically?
Yeah, spot on. I should have kept sharing my screen. Let me pull this back up. So coming back to I think if I understood your question correctly, coming back to these architecture diagrams, a big part of the value proposition is in making it really easy to expose these API endpoints on top of your data warehouse. And if you want to build the whole data warehouse with Moose, then great. Like Moose API module is going to work very natively with that. One of the directions we're going, to start to answer your question, Joe, is like modularizing even further these different elements, so that, for example, if you've already got an API framework of choice that you're using for your front end, like if you're using Fast API or something, then we want to make it really easy for you to be able to integrate in the objects and the SQL string interpolation and some of the ORMS functionality, like managing your schemas as code, getting migrations out of the box into your API framework of choice instead of having to use ours. And then alternatively, did I include this slide? I don't think I did. Let me, there's one more slide that I think is, or one more architecture that I think is pretty interesting and relevant to this question. Where is this slide? Here we go. So for teams that are already heavily invested in like a Snowflake or a Databricks, then we often see an architecture that looks something more like this, where the big move towards open table formats, being able to store your data in a data lake that is accessible through different patterns, through different personas. So you might have like Databricks as an interface with Spark for your data scientists that want their AI workbench or their notebooks. You might have Snowflake with SQL or dbt as your primary interface for your data analysts that want BI or dashboards. But then you might also run a ClickHouse query engine on top of that for your software developers or for any engineers that are building applications where you want that millisecond response time. And that's where FiveOneFour is going to give you the developer experience layer there to make it really easy to put APIs on top of your open table data lake, whether it's Iceberg or Delta Lake, whatever you're using, or put MCPs on top of it and allow LLMs and agents to interact with that. So this kind of hybrid model where you can open up your data lake to a new persona and a new category of use cases with the infrastructure that's really purpose-built for this kind of job, with something like ClickHouse, and with the developer experience that's really purpose-built for that type of persona and that type of interface for FiveOneFour. This is kind of the world that we see our users going down there.
I've got another question. There's a lot of conversation right now about data governance and data quality, and aircraft data like this is fair to partly tidy compared to a lot of what's out there. What's the right way to ask the question? Can you speak a little bit briefly about observability and building data trust when this legitimately to most people would look very automagical?
Yeah, that's a really good question. And that also points to some of the direction of where we're going as well. But there's some of that governance functionality that you're looking at, we call it data management sometimes, is already kind of baked into the capabilities of the products. Like just the fact that you have your data models as code as a source of truth that can be imported across different code bases and shared that way introduces a world where you can get governance through the software development lifecycle. So like when everything going through Git, you have peer reviews, you have pull requests, you have approvals before things make it into production. And that becomes a governance layer that's a little bit different from what I've seen many enterprises implementing, where you've got massive data governance teams of like data stewards and manual reviews and updating wikis and this whole like heavy overhead governance process can be replaced by the software development lifecycle, which is a pretty well-proven governance process for that world. That being said, data has lots of its own challenges, and one really cool use case I've seen is there's like the dead letter queue that I set up in this use case. One thing we could do is like if I send in bad data, it's going to go to that dead letter queue. And then a way we've seen people use the tool is come into Cursor and say, hey, tell me about all the data in my dead letter queue. What are the challenges with it? Okay, it turns out like, oh, this field upstream got dropped from the API or from the source. And then you just tell Cursor, okay, update my data model to match the data that's now in the dead letter queue. It's going to go and update your data model. And then you can say, all right, rerun my data through the through the stream now, like all the data that's saved in that dead letter queue, now you can reprocess it through the updated data model, and you don't lose data, and you have your updated data model enforced. So there's some level of like observability that's can be like very AI enabled in that world. All of that being said, let me flash up one kind of vision slide. I'm very curious to get your guys' take on this. This is not shared publicly anywhere yet, so this is a practical data community exclusive.
Oh, yours, we are, by the way. So
yeah, no, that's all good. That's all good. There's nothing proprietary. But thank you for the warning. So this is kind of where we're thinking about the future of the product hierarchy. So Moose Stack is what we focused on today. We've got the Copilot for Moose Stack. Boreal is our commercial platform, which I talked about, and we've got agentic capabilities that automate production management. A couple areas that we're actively building out now and investing in are, one, this idea of templates and a factory to automatically generate those templates. So we're creating a world where you can automatically generate connectors, you can automatically generate pipelines, and then publish those to a template repository. And the AI and LLMs tend to be very effective at generating these connectors because of the abstractions that are available from the Moose modules under the hood. We're going to be launching this registry, starting with the connector registry sometime in the next month or so, likely. But what we're seeing is that we're taking I don't know if anyone here is familiar with ShadCN. The idea is that, like, instead of needing to import a library, you just copy the code into your code base and then it becomes your code. We want to take a similar approach with connectors, where there's this whole library of open source connectors. You just copy the code into your code base, you tweak it as needed to make it work for you, and you're off to the races. But another area that we're also very kind of keen to invest in is what we're calling this data management layer, which would be extending the observability capabilities, the cataloging capabilities, so that if you want to go down like a full-blown data warehouse use case, but you don't want all of the overhead and expense that often comes with a lot of these massive data warehouse or data lake platforms, you can get some of that out of the box sitting on top of the Moose experience. I went a little bit off track there.
No, yeah.
Does that answer your question at all?
Yeah, it does. Specifically, like I was a recent client was trying to sort out how to take their data from their warehouse that they were constructing and get that to reflect in Calibra, for example.
Mm-hmm.
So like that lineage, and how do you you said it's creating the lineage inside, right? But how does that then get out for display for Joe in accounting to understand that this is the right calculation, right? Like that's the thing we care about. Not picking on the name Joe. It's just
yeah,
I know a guy named Joe who's in accounting. I'm just picking on him.
Yeah. So what we've got right now with Moose is there's this concept of an admin API endpoint, which is an API endpoint that comes with every Moose project, which you can hit to get information about what the structure of the project is, what the different dependencies are. It kind of gives you an entire infrastructure map. We call it the infra map. And what we've seen some users do is write kind of connectors that essentially plug into that infra map and can pull that data into your data catalog, into your observability, like data observability platform. So the lineage and information is all there. From a product perspective, what we want to do is start to make that easier to access, easier to expose with like connectors and integrations into your data management platform of choice, or potentially providing our own kind of interfaces for processing that. And then the one other thing I'll mention is observability. There's kind of two layers to that, or maybe even more, but there's at least two layers. There's the data observability, which is kind of the data management governance. Then there's also the performance observability, and like the observability into the underlying infrastructure. And for that, there's a whole observability module within Moose where we expose Prometheus endpoints. You can integrate with Datadog, Splunk, New Relic, whatever your observability platform of choice is, or just Grafana and OpenTelemetry if you want to do the open source route. So those endpoints for the observability and all of the data is there to plug into your system so that you can run this in production with confidence.
Awesome. Yeah, not enough time to squeeze all that into the demo.
Yeah, exactly. Maybe I can flash up real quick. This is all covered pretty comprehensively in our documentation. So if anyone wants to explore further, just go to docs.fiveonefour.com. You'll see the Moose documentation here with the different modules and then the different tools. So I talked about Moose observability. We talked about migrate, didn't get to show much there. And then there's Moose deploy, which is all of the tooling and packaging to get this into production in a Kubernetes cluster or whatever your kind of platform of choice is for deploying.
Cool. Thank you.
All right.
I'll stop streaming here. Then we can. Thanks a ton for this. I know we're a bit